So this is what we started last time. Again, I forgot to take a snapshot of this, so I'll put it the snapshot after. The Pepsi Machine, one soda or one kind of Pepsi and that's it. Diet Coke only, no. And it's 35 cents for it. You can only put 5 cents, 10 cents, and quarter. And this is the state diagram. We went through it and we did some coding of the states. We see we need 3 flip-flops, Q1, Q2, and Q3, and Joe wanted to use some shark flip-flops, so we use shark bait for a flip-flop, and it's a new flip-flop that we came up with. This is the excitation table for it, and we used it, and we came up with this actually, truth table now. And now our job is to design a circuit for change back for C1, C2, and C3, and also for the Pepsi and the inputs to the 3 flip-flops. And I'm going to mix and match today. I'm going to have fun with it. So the first one, let's talk about the flip-flops. We're going to have 3 of them. Each one has 2 inputs. So if I just throw the flip-flops like this, and that's the first flip-flop. That's S1, B1, Q1, and Q2. The second flip-flop, S2 and B2, Q2, Q1 not here, Q2 and Q2 not. And the third flip-flop is S3, B3, Q3, and Q3 not. And hopefully we have a clock where we can actually sync everything at the same time. We don't want them just to be fluctuating when they feel like it. There'll be a clock here. CK is a clock. And that clock also will control the change back, which I didn't even discuss yet. But I need to come up with a design for each one of these. What's going to S1, what's going to B1, what's going to S2, what's going to B2, and S3 and B3. So this is S1. This is S1. We have 5 inputs. The inputs are the current state, Q1, Q2, and Q3, and the external input, the change that you're going to put in, the money you're putting in, I1, I2. So we have 32 combinations here. So to do a K-map for that, I will have to do 2 4x4 K-maps for S1. Here's S1. So I'm going to make my K-map for S1. This is for S1, and this is 4x4 K-map. And still for S1 here, since there are 5 inputs here, I'm going to use 2 of them. And I'll use the most significant. Now, when you look at my table here, the way I wrote them down, Q1 is my most significant, Q2, 3, I1, I2. So I'll do Q2 and Q3 on the top, and I1 and I2, that's the external input on the bottom. And the first half is going to be when Q1 is 0. And this is when Q1 equals to 1. Oh, I forgot to put 2 more here. Let's fill in the blank for S1. Where's S1? Here we go. Don't care, don't care. The first 4 don't care. Here we go. X, 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 X. The next 4, 1, 2, 3, 4, don't care. We like to see that. The next group, 1, 2, 3, 4, don't cares. Oh, I put them in the wrong place. The good news is, what's the next 4?
Don't care.
Don't care. So I end up being off the hook there.
Can you circle the whole thing?
Well, let's see if I need them. I could, but if I don't need them, why circle them? Don't even use them. Because if you circle them, that's Q1 not. If you make them all ones. So I might want to make them zeros. It depends. Let's see here if they help me with this one to reduce this one. So let me do the rest now. 1, 1, 1, 0, right? Here we go. 1, 1, 1, 0. The next group, 1, 1, 0, 0. The next group, 1, 0, 0, 0. And the last one, all zeros. So what I'm going to do actually, if I just take these 4 here, which is fine, but I'm going to have Q1 in it. But if I group it with this one, what happens to Q1? It's gone, because Q1 is changing. So instead of making them zeros or don't pay attention to this, no, I can take this with this, make that group of 8, that will make it smaller. So what do I have right now? For S1, I have, let's look at Q2 is not changing, that's Q2 not. Q3 is changing, that's gone. I1 is not changing, that's I1 not. I can also take this this one with this one, and take it with these two. That's 4 now instead of 2. If I take them together, Q1 is gone. So let's look at that. What do we have? Q2 is changing, it's gone. Q3 is 0, bless you. That's Q3 not, bless you. I1 not, I2 not. And the last one, there's a 1 in the bottom. I can take this with this and take it with these two. Q2 not, Q3 not, I2 not. And that's S1. So I'm going to have an OR gate with 3 AND gates going to it. Now I need to do one for B1. So I got to do the same thing. And let's do S2 and B2. B2, I'm sorry, not S2. B2, this is when Q1 is 0. B1. I'm doing the first flip-flop. My mind has already jumped to the next one, what I'm going to do with it. I have a planning in my head. Q1 equals to 1. Q2, Q3, I1, I2. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So let's fill in the blank now for that one. This is B1, 1110, the first four. 1110. 1110 again. 1101. 1011. And the rest of them are what? And the other side? Looks like don't care. Unless I missed something. Okay. What do you see? Anything special?
The top row.
Top row. I'm looking to see if I need the top row because first to group this one here. To group this one, right? I gotta take this with this. Which means let me add to it this and that, right? Q1 is gone. Yeah, this is not a 1. If this was a 1, I would need that because I can take the 4 with the 4 there. Yep. So Q1 is gone. What do we have? Q2 not. Q3 is gone. I2 not, is it? Not a nice one here. I can also take these 4 1s, right? Because I'm not going to get rid of these 2 here. With these 4 1s. And that will be Q2 not, I1 not. Yuck. The only good news is I can take these guys here separate with these guys here and these guys here, right? This and this and this and that, and the top 2 here, I can take them 4 with 4 here. I was trying to see if I needed them. So if I group these 4 here, Q1 is gone. That's what? Q2, Q3, I1. And if I take these 4, that'll be Q2, Q3 not, and I2. And the last one, I have 2 more here. But instead of taking these 2, I'll take these 4 with these 4. And that will be I1 not, I2 not. So that's B1. S1, B1. So just if I was to build that circuit so far, and we got a long way to go to build it. I lost it somewhere. Where'd you go? Oh, I see it. There we go. This is just going to this one. S1 is going to be an OR gate with 3 AND gates. And what's going to them? That's just S1 is going to be Q2 not and I1 not. I'm not going to draw the wires. There's no way. That will look ugly. This will be 3 inputs here. Q3 not, I1 not, I2 not. And this one is going to it what? Q2 not, Q3 not, and I2 not. This one definitely uglier here. An OR gate with how many AND gates go into it? That's the first AND gate. Q2 not, I2 not. The next one. Then the next one. Then the next one. I'm not even going to label them. That's right. 1, 2, 3, 4, 5. See them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's what's going to this. There's going to be 2 lines going to it. There's going to be 3 lines, and 2 lines. That's these. That's just for this one. Now I got to do S2, B2, S3, and B3. I got to do the soda, Pepsi. I got to do the change. Well, let me get to the change. Let me wait on the rest. We're also going to have a device that will give us a change back. How much change to give? You know? So I have here C1 for change 1, C2, change 2, and C3. And what are you going to attach to them? Because that will determine the amount of cash we're going to give them back. Well, for that, maybe I'll use 3x8 decoders. Only 3x8 decoders. I'm going to mix and match. As I said, I'm going to have fun with it. For change back, we're going to use only 3x8 decoders. So I need to have, I have 16 inputs, right? A 3x8 decoder, like, how many inputs you got there? 3 control signals, 8 here, right? Well, you need 32, so you better have 4 of them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I have chip enable. Enable. I've got to make sure they are on the right time. Ideally, what I want to have a 4 or a 5x32. That's what I want to have. That's what you want to have. 5x32. 5 inputs and 32 outputs. Unfortunately, you don't have that. Well, you can get these outputs out. That's 0 through 7, right? This is, if you extend them, you can treat that as what? That's 8 through what? 15? And this will be 16 through 23. 24 through 31. That's your 32 outputs. Remember, the decoder, the way it works, has 3 control signals. That, for example, if I have here these signals, if I have 0, 1, 1, that says pin number 3 has to be high. Pin number 3. So what am I going to use? I have, for my control signals, I have Q1, that's the most significant. Q2, because it's on the left. Q3, I1, I2. I wrote them that way because that's how I label them. This digit has the biggest value on the left. The second one, Q1, Q2, Q3, I1, I2. So I'm going to use the least 3, which is these guys, and control all 3 of them, or all 4 of them. This is I2, I1, and Q3. I2, I1, Q3. I2, I1, Q3. I2, I1, Q3. Just like before. The problem with that is if you have 0, 0, 1, 1, 1, 1, 1, 1, these guys have 1, 1, 1, this guy is on, this one is on, this one is on, this one is on. I want to make sure if I have 0, 0, 1, 1, 1, only this one is on, not these 2, or not these 3. And to do that, I can still use another 3 by 8 decoder. I'm going to use Q1 here and Q2 here, and maybe I'll ground this, up to me. In my chip enable here, let's say it works on high, it's already attached to VCC. It's always high, this one. So this chip is always on. What happens when I put 0, 0? This guy is going to be on. That is my first chip enable. 0, 1, this guy is going to be on. 1, 0, and 1, 1. And I'm not using the other ones. The other ones are not being touched here, the last 4, because first you'll never reach them. Why?
One of the inputs is VCC.
Yep. Because I made the last piece to go to ground. So I don't have that piece there, so try to just separate them because they're squished together. So the first 4 actually are my chip enable for these. If I made this VCC instead of ground, that means it's always high. I'm going to use what? 4, 5, 6, and 7, my chip enables. So it depends which one I make, because I have 3 inputs. I got to make one of them ground. I only have 2 inputs. So by doing that, now I just made a 5 by 32 decoder. Well, guess what? For change 1, for C1, for C2, for C3, you got to attach the right pin. It's going to attach them. Now for change 1, let's look at change 1. 0, 0, 0, 0, 0. Oh, I see a 1, which is which one? 1, 1, 0, 1, 1. 1, 1, 0, 1, 1. What number is that? Actually, I don't even need a gate for that one. It's only 1, right? I only see 1, 1 here for change 1. Do you see any more? I don't need a gate for that one. Uh-oh, we out of space. Oh, there we go. I get some here. So C1 here is going to be just attached to which pin? 1, this value is 1, 2, 4, 8, 16. So 16 plus 8 is what? 24. 24 plus 2, which is what? 26 and 1, 27. You take pin number 27 from down here and you attach it to that one. C2 here, the change for number 2, I need this one, this one, this one, this one, this one, this one. This one happens to be, that's 16 plus 2 is 18 and 1 is 19. I need pin 19. 16 and 4 is 20. What was that number? What did I say? 16 and 2 is 18, 1, 19. Yep. 16 plus 4, that's 20. 22, 23, that's pin 23 attached to it. And now what about this one? That's 31, 30, 29, 28. 28, 29, 30, and 31. And change 3, I need the last 4 again. 31, 30, 29, 28. What else do I need? That's these guys on the bottom. I also need this one, which is 26. I need this one, 26, 25, 24, 23. And I have one more, I think. 22, 21, 20, 19, 18, 17, 16, and 15. This will take care of the change back for me. Done with C1, C2, and C3. We designed them.
And how would it just attach the decoder to?
There's nothing. Decoder? Oh yeah, the decoder is attached to Q1. Like, well, you have 4 of them. You see, you got all these decoders. You got to attach I1, I2, and Q3 right there, and Q1, Q2.
Yeah, but I'm saying would it be attached to the main
Yep.
scheme?
Q1 is actually, when I say Q1, is this wire is going to be, right? This wire is going to right there. Q2, this wire is going right here. Q3, this wire here, is going to this, and that. And I1, I2, that's your external input. So now we finished with C1, C2, C3, S1, B1. We're making progress. So this is wire, this is an OR gate here. And we have these done. Now what about S2 and B2 and S3 and B3 and maybe Z? We'll see what we're going to do with that, with the soda, Pepsi. Let's have fun with them. Maybe for Z, I'm going to use 16 by 1 mux for the Pepsi.
So it'd be two 16 by 1?
No, I'm only going to use one of them, actually. I'm going to just use only one 16 by 1 mux I'm going to use.
You can use 2 though, right? Technically.
I could use 2 and use chip enable for them and all that. So I'll make it clean. For Z, use only, you don't need it. Your circuit's already a mess. 1 16 by 1 mux. And what I'm going to do with that, 16 by 1 looks like this. The mux, we drew it last time looking like this. Has 16 inputs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It has 4 control signals. 1, 2, 3, 4. Q1, Q2, Q3, I1. And this attached to Z. If that's high, give them Pepsi. If that's low, don't give them Pepsi. Now,
So I2 is going to be our variable.
correct. Here is Z. Pepsi. Let me put them right there. Easier on the eye. Do we have a tape here? Question, if we build this in the lab, how many of them will work? Correct. How many things will build right? I'll go with 0. I'm not optimistic in you. That includes me. And I think I'm good at good doing them, but to make a mistake with that many wires, very easy. So imagine people do this all day long. Now let's look at Z. Let's look when it's 0, 0, 0. That's these two cases. What do you notice about Z? Always 0. Doesn't matter what I2 is. That's perfect. Ground. The next two, 0. The next one, 0. Next one, 0. The next one, 0. So 1, 2, 3, 4, 5. The first 5 attached to 0. To ground. Now let's look right here. Uh-oh. I'm a little bit off down, huh? Now, the next group is right there. Is that where the next group, or am I off by a little bit?
You're off. I think you're going up one.
Going up? It should be this way?
Yeah.
Okay. So that looks like 0, 1, 1, 0. What do you notice?
They just flip.
They're flipped. That's I2 not. The next group, 0, 0. That's still 0 ground. So let's go back and attach it to ground. So this is not attached. That's why I don't put a dot there. The next group, 0, 1, 1, 0. I2 not, right? The next group, 0. The next group, I2 not. The next group, 0. The next one, VCC. The next one, I2 not. And the next one, VCC, VCC. Oh, looks like I'm missing one here. Did I miss one? That was good.
That's probably where.
Here we go.
So it's actually I2.
Is it I2 for all of them? It looks like it, yeah.
It's just not I2 now, it's just I2.
I2, yep, because I was off like with the thing. And the last one's what? VCC? The last 4? I hope I was right with them. I was crooked up there.
So VCC's for the last 3?
The last 4, I think 4 or 3, yes. And there's one before it. Here we go. There's 1, there's 2, 3, 4. So 1, 2, 3, 1, 2, 3. Not this one, that one.
So there's ground, I2, ground, I2.
What about if I peel that paper and move it up a little bit? Is that better? I got a clean one here. I can do another clean one. Make it easy on me. I should have like this. Maybe I'll do that for the next set. That's a clean one. Here we go. We go 0, 0, 0, 0, 0. I couldn't tell you what they line up with. definitely need a ruler for these. Like this. Just to make, You look at them that way. You get the idea, I think. And now we can go and design the rest of them. We need to design one for S2. We did that. This one, that's ready to go connected. Now we have two more, S2, B2, S3, B3. We can decide what we're going to use.
Do you use two muxes?
I can use muxes, I can use ROM, I can use PLA, I can use PAL.
So I probably like muxes last.
Well, muxes will make it actually nice and clean. That's what they do, you know. You can use gates, whatever, you know. It really, preference for the design. I'll let you have fun with it. Because I'm looking at the clock. There's no way we're going to finish it. So you can design the other two, whatever you want to use for them, and that's what control the rest of it.
Will we have time to go over like the exam, like what's going to be on the exam?
Which test?
The for Tuesday.